So hello, thanks for coming. Today I would like to tell you a bit about our experiences with using Elixir for quite a long time. And it all starts with the company I currently work for. We're called Appionite, and in 2015 we were mainly a Ruby on Rails shop. We were using this technology for different kind of projects, and one of them involved creating a chat component as a main part of the application. So we knew that Ruby and Elixir and Rails are not the best technologies for this kind of problem, which involves a lot of real-time connections, possibly high traffic. So we started looking for a different tool. And my boss was aware of Erlang and its features, and he knew that Erlang was a great tool for this kind of problems. But he also knew that it's a bit strange and it's a bit unfamiliar for Ruby developers. So he found out about this new language called Elixir. And after doing some research, he decided to use this language and to create a first prototype of the application. So in August the 12th, 2015, we pushed our first Elixir commit to our GitLab repository. And at that time, Elixir was a new language. It was only 1.0, which had been released a year before that. Neither Ecto nor Phoenix were 1.0 yet, so we were using software that was changing quite frequently. So we also didn't have a lot of resources. We had to rely on official documentation only because all the tutorials and articles were quickly going out of date. We didn't have so many conferences, so we couldn't have just watched conference talks. We couldn't have listened to podcasts. There was only the book Programming Elixir by Dave Thomas and I think Elixir in Action by Sasha Yurik. So we didn't get a lot of references to learn from. Also, the community back then was hugely influenced by the Ruby ecosystem and by the Rails ecosystem. So for example, we have this concept of ecto callbacks back then. And as you could see, we also have ecto models, not schemas. So the language was quite different. The community was a little bit smaller, and we didn't have a lot of resources. And we didn't know if the project was going to be successful. Yet here I am 3 years later, and I am standing at Elixir conference, which has been growing for the past 5 years. So it turned out that both the language and our project had been successful. So a lot has changed because we are using recent versions of Elixir, Phoenix, OTP, and Ecto. We have been running for more than 2 years in production. We have written and we are maintaining more than 70,000 lines of code, although we try as hard as possible to keep this number lower by deleting as much as we can. We have a lot of happy users. We are serving more than 1 million registered users, which are happy because we are able to deliver features quickly. We are able to fix bugs because Elixir is such a good language. And we're able to provide quite reliable software. So we have a lot of happy developers because of that. Since we started this project and during the time that we have developed this project, we also started developing all the new projects we do in Elixir. We started convincing our clients that Elixir is probably the best solution and tool for them to use. So because we have this experience, I've been wondering what is so special about Elixir, what made us switch from Ruby that we loved so much, and what made us stay with Elixir for all this time. So I've been watching a lot of conference talks. I've been reading a lot of blog posts and articles explaining the experiences with Elixir, explaining why Elixir matters and it's important. And most of the resources are saying that these things are the reasons to choose Elixir. They are happy with functional programming because they say that immutability, functional programming, and all of this stuff is making the code easier and more pleasurable to work with. They are happy that because of the Erlang virtual machine, we can create massively concurrent systems. We can distribute those systems and take care of these things. We have a lot of great things to care about fault tolerance. We have all the tools from OTP. And while all of these things matter and are terribly important, I think that for us, the reasons to stay with Elixir are a little bit different. So I would like to start today with the Rails way, because as Ruby developers, we were used to a certain way of creating applications. This way was hugely influenced by the framework and the libraries. We followed conventions imposed on us by Rails. We followed the directory structure. We follow all of the best practices for Rails developing. And because most of the Elixir community back then was Ruby developers, we started doing the same things in Elixir and Phoenix. So in 2016, Lance Halvorsen gave a talk entitled "Phoenix is not your application" at ElixirCOnf. And in this talk, he told that we shouldn't be doing that. We shouldn't be thinking that we are building Phoenix applications. So he said that we shouldn't use the framework so much. And we went from building this thing. We went from building traditional MVC apps to something more like this. And this had some benefits that were quite obvious. So you have the isolation, so you can test your application without having to worry about a web interface. You have a separation, so you can reason about your application easier. But it also makes us quite confused, because we started asking questions like, okay, so how should I actually structure my application? I had this clean structure before, and now I have no idea where should I put this code, where should I put this module, or how should I even call this module? And this introduced a lot of confusion into the ecosystem, but it started a transformation that eventually led to developing of Phoenix context. And while some people were really dissatisfied with the solution, because some said that Phoenix shouldn't be concerned at all with these things. Some said that Phoenix is not doing enough. It is not explaining how to structure our application in the correct way. I think that this trend, this movement, was a first step to creating better Elixir application. And I will come back to these topics, but now I would like to move a bit to concurrency, because as I've said, concurrency is one of the best aspects of Elixir, and it is often used as a reason to use the language. But the problem I have with the term, that is when I hear massive concurrency, I always go back to those years spent in college during computer science courses, when we were learning about concurrency in things like C++ or Java. And I am thinking about this stuff when we have a lot of processes or threads running at the same time that we have to coordinate somehow. And this stuff is terribly hard. But in Elixir, what concurrency means is that you can create this. You can create your software as a simple functions that are running one after another, without having to worry that some of the functions are slow because they use some blocking I/O operations, without having to worry that some of the functions may fail, because you know that because of you have this isolation of processes, the failures of some functions or the fact that some functions are slow wouldn't affect the system that you are creating. It wouldn't affect other requests and other processes. And this is true for both, for example, Phoenix requests, but it is also true for things like Gen servers and processes that are more short-lived. So Joe Armstrong once written in a blog post that in Elixir and Erlang, we don't have one web server that handles 2 million requests or 2 million sessions, but we have 2 million web servers, and each is handling only one request at a time. And this is a really powerful concept, because it means that we can care about this one request only. We can care about only one user at the time. It also means that when we create software, its behavior, its fault tolerance, and its performance become separate concerns that can be worked on separately. So when you start creating your system, you can start with this. You can program your behavior using simple functions, and you don't have to use all of these try-catch constructs. You don't have to check error codes. You don't have to use things like futures and callbacks to handle blocking I/O operations. If you think about it, Elixir is the only language I know that allows you to do stuff like that. In all of the other language, your code and your domain logic is often entangled with the performance-related and fault-tolerant related code. So in Elixir, you can start with that. Then, if you have the behavior ready, you can take care of performance by, for example, running some code in parallel. Then, if your code runs fast enough, you can start taking care of fault tolerance, for example, by adding some links and monitors, which monitor if the process is doing okay. You can put the process under a supervision tree to provide better fault tolerance. It all comes down to this, that Elixir, as Sasha Yurik said in his talk once, provides you this solid ground, this solid foundation upon which you can build your software without having to care about all the hard stuff that you have to care about in other languages. It also means that when working on a problem, you have to keep only one thing in mind. You don't have to worry about behavior, fault tolerance, and performance at the same time. You can focus only on one thing, which makes your work really easier, and it makes you more efficient because you don't have to do this context switching all the time. It also means that when you are a beginner or when you have a beginner programmer in your team, they can take care of behavior and write simple functions, and they can then consult with someone with more experience to help them make it fault tolerant, make it fast. And this is extremely powerful concept. So I was supposed to talk today about what has changed, and this was my idea for the presentation. And I was looking at our older code. I was looking at the commits that upgraded the versions of Elixir or Phoenix or Ecto. I've been looking at changelogs for all those things. I've been also comparing the topics from conferences from 2015 and from now. I've been reading articles and watching topics on forum, and I came to the conclusion that, to be honest, not much has changed. Of course, Elixir got some new cool features. It gave us performance improvements almost for free. But in terms of the way that we are developing software, Elixir didn't introduce anything new, and any other library in the ecosystem didn't introduce anything new. And we as a team and as a community in general learned more about Elixir. We learned to appreciate functional programming. We learned more about OTP. We learned to appreciate concurrency. But the most important part is that we learned more about software engineering in general. We learned more about our domain logic and problems associated with this domain logic. And this brings me to the best thing in Elixir, and the reason that Elixir is so good, in my opinion, and it allows us to be so productive, is that Elixir is transparent, and all the libraries in the ecosystem are transparent. Compared with Rails or any other technology, Elixir just gets out of the way and allows you to focus on the problem that is really important without having to fight the framework, fight the language. Of course, being so great is only one side, because I think that all tools have disadvantages. So I also believe that knowing these disadvantages is really important, because if you want to know some tool or some approach well, you have to understand its limitations and problems with this tool. So I've been wondering, what are the problems of Elixir? And of course we have the obvious ones. We know that Elixir is not so good when it comes to math and intensive computations. We know that when you want to do machine learning or artificial intelligence, Elixir is probably not the best tool to do that. We know that when you want to create a hard real-time software, so stuff that controls heavy machinery like factories, Elixir is probably not going to be a good tool. But I'm not satisfied with these disadvantages, because if you think about it, for all of those problems, you have only few specialized tools that you would use. You wouldn't use things like JavaScript or Ruby for highly intensive computations. You wouldn't use these tools for hard real-time software. So I have been wondering, what are the disadvantages of Elixir when compared to more general purpose programming languages like Ruby, Elixir, Ruby, JavaScript, or Python. And I think that the most dangerous disadvantages are the ones that we are not afraid of, or even the ones that we think are good tools, good things, because they are the things that bite us in the future. So if you think about all the things that make Elixir great, so if you think about massive concurrency and distribution and fault tolerance and OTP, you might realize that these are dangerous concepts, because the fact that we have them built in can make us a bit ignorant. My favorite example is distribution. We are so used to hearing that Elixir and Erlang are great for creating distributed systems that we tend to do this even though we don't know the theory, we don't know the limitations, we don't know how the distribution actually works. And it was actually one of our most annoying mistakes, that we started to use distribution protocol for Erlang without realizing the problems associated with this. So this resulted in bugs that were really hard to track, because everything worked well locally and everything worked well on production most of the time. But when you lose this one message out of 1,000, and you have millions of messages coming to the system every day, it starts accumulating and it starts being a problem. So we know that we come from these technologies. We know that Erlang has been a huge inspiration, and because of Erlang, Elixir looks like it does. We share the same principles, we share the same runtime, we compile to the same bytecode. We are also hugely influenced by Ruby and Rails communities, and we got a lot of good things from them. We got the syntax, we got the idea that programming should be fun and easy to do. We are also inspired by Clojure. We got macros and protocols from Clojure. We got Ecto syntax from Linku in C#. But understanding the benefits of these technologies and understanding the drawbacks are not enough. Why shouldn't we look at other tools in the ecosystem? A lot of people are saying that akka is just a copy of Erlang in the JVM world. But when you look at akka and you look at what are the tools that akka provide out of the box, you have amazing stuff like distributed data. That is a way to have distributed data in memory across the cluster. It is based on CRDTs, which are becoming a hot topic in the Elixir world. And some people are trying to implement CRDTs in Elixir. So why not look at akka and see what the problems are associated with this approach? What probably are the performance limitations? Let's learn what mistakes people in akka did when they were trying to implement that. They have support for something like persistent actors. So if you went to Lance's talk today when he talked about using Elixir for warehouse management, he were describing the pattern of spawning the processes just in time where they are needed and saving the state in the database. This is all supported out of the box in akka. They also have support for cluster sharding, which is a thing that we also need in Elixir and are struggling a bit to implement. They have amazing support for streaming, which is quite nice when you are dealing with a lot of data. So I'm not saying that we should go and copy the stuff, that we should put this stuff in the core language, because like Jose said, we are trying to keep the Elixir small, but why not take inspiration? Going next, we have this actor implementation in .NET Word called Orleans that have some amazing ideas about how to implement those actors. Why not take a look at that and try to learn something? Next is Haskell. A lot of people are wondering what would be like to implement a type system in Elixir. We heard about this from Jose today. But in Haskell, there's a project called Cloud Haskell that tries to implement an Erlang-like concurrency model into Haskell, which already has strong type system. So maybe you can take a look at the problem from their perspective and see how it's like to implement concurrency when you already have type system and what are the problems there. Maybe it will help us to introduce a type system to existing concurrency model. Things like Golang and Rust. A lot of people are mocking Golang for being too simple, but it introduced a concurrency model that is so simple that even beginners can easily understand. Rust is, on the other hand, doing something completely different when it comes to shared mutable state. That is the main problem in concurrent systems. Let's look at Docker. A lot of people are wondering whether Docker is a good fit for Erlang and Elixir. A lot of people are saying that it doesn't. But we shouldn't ignore that the whole world is going towards containerized deployments. And maybe instead of fighting this and ignoring this trend, we should try to imagine what it would be look like to introduce things like hot swapping into containers. A lot of people are saying that AWS Lambda and serverless computing are complete opposite of what Erlang does, because in Erlang we have this long-lived servers that are running for a long time and doing things. In serverless, we have short-lived functions that only do one thing and die. But when you go a bit deeper, you see that Lambda functions are all about isolation. They are all about not sharing any memory or resources. They are executed when some events happen. They are scheduled by some outside scheduler for the runtime. And even though it seems completely different from Erlang, these things are really familiar. These are the same concept and core ideas that are underlying in Erlang. So we should learn from all these technologies. We can learn, for example, by looking at Kubernetes and gRPC and trying to figure out how other people are using these technologies to create distributed systems instead of going to Erlang distribution protocol by default. So Aristotle had this quote that it is not once nor twice that the idea comes into the world by times without number. And I think it is particularly true for computer programming. We all probably know by now that Erlang is based on the same concept as object-oriented programming, that is messaging and isolation. But there are other examples. For example, when we think about processes, we often say that Elixir processes or Erlang processes are completely different than processes from operating system. But In fact, they are built on the same core idea, that is isolation. And without this isolation, neither Erlang or OS processes wouldn't make any sense. The only difference is that Erlang processes are optimized to take less resources, but the concept is the same. So maybe instead of learning about Elixir more, we should learn about this core concept in computer science. We should learn about software architecture and stuff like domain-driven design. We should learn about theory of distributed systems if we wanted to use them. We should learn about the limitations and then compare the limitations with what Erlang does when it's running a cluster of nodes. We should learn about data structure and algorithms and ways to make our programs more efficient and more simple. And we should not forget that we have a lot of knowledge accumulated during all these times of developing object-oriented software. We have all the amazing design patterns that some of the people are saying it is not important in functional programming. I heard a lot of times that functional programming is just modules and functions. But this is a diagram of dependencies between modules in our project. It is only one application in Umbrella where there is more than 15 right now. And when you reach a certain scale and a certain level of complexity, saying that it's just modules and functions is not enough. You have to have some foundations and some design patterns to make it clean. So let's learn about these big ideas and things that are shared across the languages, across the ecosystems and communities. Let's learn from other programmers who are not using Elixir. We started today by saying that Phoenix is not your application. And the point of my talk is that I hope that by now you realize that we are not building Elixir applications either. So I hope that we will not become Elixir developers in the future, that we will not be so focused on the language itself and the platform. I hope that we will continue to question the choices made by Elixir core team. We will continue to question our origins. We will continue to question whether Erlang is a good fit for all the applications and if using something else will be better. So let's continue to use this language because it is amazing, and I think it's one of the best tools that we have, especially for creating this kind of system like web systems. But we now see that stuff like nerfs is also possible. And it is all due to the fact that Elixir doesn't make any assumptions about how we should create software. So let's also not make these assumptions and not be constrained by the language. And with that, I thank you for coming. I am Maciej, and I work for a company called Apionite from Poland. And if you have any questions, I will be happy to take them.
Do you have any questions?
So over the last 3 years that you've been running Elixir in production, things have probably changed in terms of state-of-the-art for deployment. How have you kept up or not kept up with those changes?
Actually, from the beginning, we've been using releases and the distillery. And to be honest, in that area, nothing has changed as much. Recently, we've switched to using Docker and Kubernetes. And we've been a bit hesitant because we all know that it's maybe not a good idea. You don't get to use things like hot upgrades, but we decided that the benefits of running containers and running Kubernetes and having stuff like rolling upgrades and canary deployments and all of this stuff is much important for us than having all the great things in Erlang community.
Anyone else?
Other than Elixir itself, are there other programming languages that you use in other parts of your ecosystem, and how does the language interop work or interprocess stuff?
So we are still maintaining the Rails application because I've told you about the project, and we started developing the chat component in Elixir while maintaining the Rails part as the rest. Over the time, we've moved all the new development to Elixir, but we're still maintaining the old one, and we'll probably do forever because it just doesn't make sense to rewrite all this stuff. But apart from that, and the language obviously for the client side, no, we are not using anything other than Elixir, which is great.
That's a really awesome talk, and I love the philosophy
Thank
that you're
you.
putting forward. How do you think a language community can prevent itself from crystallizing into a hard, because Rails started out, or the Ruby community started out a little more wide open, and then it eventually became, this is our way of doing things.
I think actually the core teams are doing an amazing work in this area. So like Jose have been saying in his keynote today, and actually in all of his keynotes that I am aware of, he's not trying to make Elixir something more than this small core, but also Chris McCord is working towards making Phoenix really small. Guys from Ecto is doing the same things. And the fact that they are not trying to make their libraries something that they shouldn't be is amazing. But also we have these amazing people in the community. We have people like Dave Thomas, who is always questioning the things that we take for granted. And I think listening to those guys and thinking for ourselves what is the best for us and not just relying on the defaults that we have, we're gonna do just fine.
Anyone else? Okay, thank you.
Okay, thank you guys for coming.